So hello, today we will be doing the question on Leetcode, which is adjacent increasing Subarrays detection, second part. So this is question number 3350, as you can see on the Leetcode. Now what this question says is actually that so first part is also given, but the constraint difference is there. So we can do the first question like through the brute force, because the questions of subarrays can be done, using the brute force technique, which will be like exploring all the subarrays. So firstly we will discuss this question. So as written in the question, like we have given an array. So so here in this question we have given an array nums of an integer, and our task is to find the maximum value of k for which there exist two adjacent subarrays of length k each. So basically what is happening, we have to find the two adjacent subarrays of length k such that both the subarrays are strictly increasing and they should be adjacent. So two conditions are there, that both subarrays are strictly increasing. Like the first condition is this, and the second condition is this, that b is equals to a plus k. So these two conditions are there. Now this is question is pretty clear, that we have to find the maximum possible value of k, we have to return that. So firstly, seeing the topic of subarrays, the first intuition came in our mind is actually of using the sliding window, because when we are talking about the subarray questions, if you have like studied decent DSA, then we got the intuition of sliding window very first in seeing the questions of the subarrays. So now if I came on the test cases that has been given in the question are the necessary and sufficient test cases, because the approach I have formed of the of this for this question, that I have observed from these two test cases only. So what is happening, actually I have written some of the key point, that the first key point is actually is to observe the test case. So that if like the first test cases, so if we see the test case, then there can be two condition. As you're seeing, the first condition, the first is where I'm getting the first subarray as 789 and the second subarray as 234. So 789 is strictly increasing, okay, then I got just the adjacent subarray which is 234, but also I am getting a one subarray which is 25789 and also 234 then, okay, but obviously both should be of same length. But we can like balance out, okay, like if I'm getting an increasing subarray at first and then another increasing subarray, then to balance the length I can just take the minimum of both the lengths. Okay, so that is pretty clear, there is no problem in that. Okay, now what is happening in the second test case is that here I am getting like 1 2 3 4, and then the equal numbers integers being repeated, and then I'm getting the 5 6 7. So here I'm not getting a contiguous, okay, you will say okay, 1 2 3 4 I'm getting, and then 5 6 7, but obviously these both are not adjacent. So obviously in this case, in this test case, I have observed, okay, in itself 1 2 3 4, like if I'm having like one continuous of like some length of some length n, if I'm getting of some length n a subarray which is strictly increasing, obviously I can divide that subarray in half of the length. So obviously, and then both of those subarrays will also be adjacent and will also be strictly increasing, so there will be no problem. So from this test case I have got this intuition. So two things I got from here. Now what I have written, that okay, so to use the sliding window, there is a general essence of the sliding window, that there is always a left pointer, there is always a right pointer, and the right pointer keep increasing while a condition being true, and then when the condition goes wrong, then we came out of the loop, and then we update our length or whatever the metric we have to optimize, and also to update the left so that to start the new window. Now here in this question, what is actually the condition is. The condition is obviously when we will get, so here I am in case of the wrong condition. So if I get some new element, if new element is smaller and if the new element is equal, so in both the cases, right, in both the cases, so in both the cases, okay, so in both the cases my window will ends, and then okay, so till here I have get one subarray which is strictly increasing, and I can just record its length, and I can go for both the cases. Like I can compare, like I have not to compare, but I can just go with the previous length, taking the minimum of the previous length and the current length I have got, and then updating the max. Or the second thing the second thing I will do to obviously half this length only, because to get to the to get this condition that we have also seen in this test case, that for 1 2 3 4 I am being dividing the 1 2 3 4 subarray into two halves. So now here I have done the dry run for also. So in this test case, like 5, in this test case 2 5 7 8 9 2 3 4 3 1. So here in this, these are the indexes, okay, and I have initialized right as 1 because I will be like comparing this character from the previous character, so I have to keep right at one index more. So it like for this reason I have incremented right to 1. So it is being like compared in the while loop, like okay, 2 less than 5, right will be incremented to 1. Okay, in this case right is initially 1, but then right will be incremented to 2, right. Then at the 2, then the element at the 2 will be compared from the element at the 1, which is 5. So 5 less than 7, again right will be incremented to the 3. Then the element at the 3, which is 8, will be compared from 7, which is again greater than. So then right will be incremented to 4, and then element at 4, which is 9, here we can see, then it will be compared, it is also strictly increasing. Then right will be incremented at 5 to 5. So when the element at 5 is 2, which is obviously is less than 9, not greater than 9, so here the condition goes wrong. So now my right is 5 and the left is 0 initially, which I have initialized. So what will happen, that now I will calculate my length, which will be simply right minus left, because it is like having the extra index which is being incremented in the while loop itself. So there is no need to do plus 1, so I can just simply do right minus left, which from which I will get 5. Now what I have discussed the second, according to that second test case, that while calculating the 1 2 3 4 I would get length as 4. So doing the length dividing by 2, getting the length as 2. So this is like the first updation I will do in my length, maximum length, final answer. And then I will update my left to 5, which is starting new window, and then right will be incremented to 6, the next element. So the element at 6 will be comparing will be compared with the previous element, which is at 5. So first subarray we got, which is 2 5 7 8 9, and there is no previous subarray, so I have my previous length initialized to 0 only, right. Now at next discussing point is why we maintain previous length to compare with the previous subarray length. Obviously every time updating previous length is equals to length, so that we always keep track of adjacent subarrays. So now for taking common length of both the subarrays, I have to do minimum of the current length, which is being stored in length variable, and with the previous length, so that I can get the like the common length in between both the subarrays. So if I'm like getting the previous subarray of length 4 and the current is of 3, then obviously I can take the 3 element of the previous subarray, so the minimum length would come out to be 3. Then further incrementing the right. So for further part, 2 less than 3 right will be incremented to 7. Then the element at 7, which is 4, again right will be incremented to 8. Now element at 8, which is 3, is less than 4, so condition goes wrong, and the length, which will be now 8 minus 5, because left was updated to the 5, so length I got now is 3. So subarray I got now is 234. So now I will do, because previous length will what was updated to 5 when I got the array, of the length 5 previously. So minimum of 3 and 5 would get 3 to get the common length obviously. And then left become 8, right become 9, and then 3 greater than 1, again condition goes wrong. Length is 1, so length will not be updated now, because max length is already 3, so it will not be updated. And then right become 10, and the loop ended. Okay, because 10 is the length of the subarray, of the whole of the array itself. So the max length we got is actually 3. Okay, so here is how we have done all this question completely using the sliding window technique. And if I have to show the code, then here is the code in Java. So here I have done initialize left to right, left to 0 and right to 1, and is the size of the list. Okay, here we have the list in Java. And then max length initialize to 1, because 1 can always be the answer as of the single element. And then previous length is like 0, previous length obviously to maintain the previous length, the length of the previous subarray. Here is the first while loop in which we are incrementing right as much as possible, and then here we are calculating the length. Okay, if length is greater than 1, obviously in one length we can't do half, because it must at least of length of 2 to be divided into two subarrays. And then updating, this is step for updating left, this is like now updating the right. Okay, obviously here in this value, when the condition goes wrong, obviously I am at the new window now. But obviously I am always comparing with the previous element. As you can see, nums dot get at right minus 1 less than nums dot get at right. So for that I have to again increment the right. Now previous length is not equal to 0, because if I'm processing the first subarray itself, then previous length is obviously 0. But if it is not equal to 0, means I've already processed one subarray previously, then I can compare this length to this current length and the previous length, and being stored in length 2 variable, and then can update the max then. So here I'm also updating the max, because obviously that single subarray, if it can be divided into two subarrays, if length is greater than 1 obviously, then obviously can have can be considered as the answer as two subarrays in itself. And then the previous length is being updated to length every time, so as to maintain the adjacent subarray's length always. And then when obviously this condition will be reached, right less than n, the whole array will be processed, I will be returning max. So this is how the whole sliding window approach goes in this question.